Hello everyone, welcome back. This is Engineer Sam Wasapi. So this is a continuation of our exam preparation. Alright, so in this context, we've been taught to find the value or values of P, for which the matrix, that guy there, is singular. So now one thing you should understand is that whenever you're looking at matrices, or the matrix rather, they are referred to as rectangular array diagrams. So in a common knowledge, I would say whenever they say something is singular, just be mindful that the determinant will be equated to what? 0. So a singular matrix is basically a matrix whose determinant is 0. So now, why is that information given to us? We need to find the value of values of P. So if it's singular, we're just going to find the determinant and set the det to 0, and so for P. So we know that the determinant is major minus minor. Yeah, so we say det is equal to the major diagonal, which is 2p minus 1 times 4p plus 2. So it's major minus minor, which is having 2p plus 1, then p plus 1. Okay, so we can just do up a simple data by the side, expand what we're having. We have 2p multiplying 4p plus 2, then we have minus 1 multiplying 4p plus 2. Now 2p times 4p, that is like 8p squared, and 2p by 2, that's like 4p. Then you have minus 4p, minus 2. So you have 8p squared, we know this will go to 0, then minus 2. So for that one, we can do the other one as well. So that would be like 2p times p plus 1, and that would be like plus 1 times p plus 1. So 2p by p, that is 2p squared. 2p by 1, that is 2p, then you get plus p plus 1. So you have 2p squared plus 3p plus 1. Alright, so now let's put it back. So we're having det is equal to, the first part is 8p squared minus 2, then minus what we're having now, which is 2p squared plus 3p plus 1. So we know that the det is singular, so it's going to be 0. So we have 8p squared minus 2 minus 2p squared minus 3p minus 1. So it's okay to flip the equation. So we can have 8p minus 2p squared minus 2 minus 1 minus 3p, and this is equal to 0. So we have 6p squared if we do up the algebra there, then minus 3p, then minus 3 is equal to 0. Now as you can see, if you have this, you can just find the factors. But since we're having like common coefficients here, which can be reduced, we can just say, okay, the entire equation divided by that. So we end up having something like 2p squared minus p minus 1 is equal to 0. Okay, so let's find the sum, the product, and the factors. So we know the sum is minus 1, the product is minus 2, so the factors is minus 2 and 1. So you know this would be 2p squared minus 2p minus 1, sorry, plus 1p then minus p. And you can factorize this by grouping, grouped. So if we factor out the value, we have 2p, then we have p minus 1. We can also pour out what here? We can also get, can factor out something here. Okay. We can factor out, why am I having p and p? Can anyone find the mistake? Okay guys, as you can see, there's a simple error just done there. Yeah, there's a simple error. So you have minus that, then you put the 2 there, then you have p, and 1. Yeah, there it is. So if you just put out 1 here, we end up having p minus 1 then is equal to 0, put a plus there, can just put out 1, p minus 1, then 2p plus 1, and this is equal to 0. So we know that one of the values of p will just be p minus 1 being equal to 0, so p is what? 1. Then we have 2p plus 1 is equal to 0, so we know that p is now going to be negative half. Okay, so that's how you find the values of p. Yeah, I hope you didn't glitch. Alright, thanks for watching, and yeah, don't forget to like and subscribe.